A single artillery shell takes approximately 4 seconds to travel 3 kilometers. 4 seconds of supersonic flight, then silence, then impact. The Russian crew that fired it had maybe 90 seconds to displace before a Ukrainian counter-battery radar finished its track, a drone confirmed the position, and a return volley was already in the air. Most of them didn't make it. This is the story of 21 self-propelled guns, Msta-S howitzers, 2 S-19s, 2 S-3 Akatsiya systems, lost in a single frontline sector over a compressed period of weeks. Not to a single dramatic strike, not to a breakthrough operation, but to a systematic, sensor-driven process that the crews on the receiving end described in intercepted communications as feeling like being hunted in the dark. By the time you finish watching this, you'll understand exactly how that hunting worked. You'll understand the sensor-to-shooter chain that turned Russian firing positions into recurring targets. And you'll understand why displacement discipline, one of the oldest survival rules in artillery warfare, collapsed so completely that the same coordinates were struck multiple times, sometimes within hours of each other. The central question isn't just how Ukraine destroyed 21 guns, it's why Russia couldn't stop it from happening again, and again, and again. Let's go to the map. The sector stretches along a roughly 40-kilometer axis in eastern Ukraine. Without naming specific coordinates that would compromise ongoing operations, we can describe the terrain. Flat agricultural land broken by tree lines, scattered settlements, and a network of dirt roads that turn to mud in the spring thaw and freeze solid in winter. This is not dramatic terrain. No mountains, no cliffs, no natural fortifications. What there is sight lines. Long, flat sight lines extending for kilometers in every direction. For artillery, this terrain cuts both ways. Flat ground means your shells travel predictably. It also means that when you fire, the acoustic signature carries further. The backblast is visible from greater distances. And counter-battery radar, the AN/TPQ-36 Firefinder and the Ukrainian-operated Arthur systems, can track your round from impact back to your barrel with remarkable precision on terrain like this. By early 2024, Ukrainian forces had established what military planners call a sensor-to-shooter network across this sector. The term sounds technical. The reality is both elegant and brutal. Here is how it worked. A Russian self-propelled gun crew sets up a firing position. They have doctrine for this. The Russian artillery manual prescribes specific procedures for site selection, camouflage, and displacement after firing. The problem is that doctrine assumes the enemy needs time to process information. In this sector, that assumption was catastrophically wrong. Step 1. Detection. Ukrainian counter-battery radar picks up the outgoing round within seconds of firing. The radar plots the shell's trajectory, calculates the point of origin, and transmits coordinates. This takes less than 30 seconds. On flat terrain with a clear radar aperture, the accuracy is within 20 to 50 meters. Step 2. Confirmation. A Ukrainian drone, typically a Mavic 3 or a modified commercial quadcopter, is already operating in the area or is scrambled within minutes of the radar alert. The drone operator receives the coordinates, navigates to the location, and visually confirms the target. Is the gun still there? Has it displaced? Are there vehicles nearby? This visual confirmation takes 2 to 4 minutes depending on drone proximity to the target. Step 3. Fires. Once confirmed, the fire mission goes to a Ukrainian gun line or rocket system. The time from radar detection to first return round can be as short as 4 minutes in optimized conditions. Even in average conditions, Ukrainian forces in this sector were achieving fire missions in under 8 minutes. 8 minutes. That is the window a Russian crew had to fire, pack up a 27-ton self-propelled gun, and move to a different position. Russian artillery doctrine calls for displacement within 2 to 3 minutes of firing in high-threat environments. In practice, on the battlefield in 2024, crews were taking 5 to 10 minutes or more. The math is unforgiving. Russia entered this sector with a considerable artillery advantage in raw numbers. Before the losses began accumulating, Russian forces in the sector could draw on an estimated grouping of 60 to 80 tube artillery pieces, including the 2S-19 Msta-S, a 152mm self-propelled howitzer that forms the backbone of Russian divisional artillery. The Msta-S is a capable system, a 42-ton vehicle with a range of roughly 25 kilometers on standard ammunition, 40 kilometers with base bleed extended range rounds, and a rate of fire of 6 to 8 rounds per minute at maximum. It's a serious weapon built for a serious war. The problem wasn't the equipment. The problem was how it was being used. Here's the part I kept coming back to when going through the battle damage assessment reports and the geolocated strike footage. The comparison that defined this entire engagement isn't about firepower. It's about time. Russia had 60-plus guns and the firepower advantage. Ukraine had a sensor network and a processing speed advantage. In this sector, processing speed won. Russian artillery doctrine, as practiced in this war, reflects habits developed in environments where counter-battery response was slow, radar coverage was incomplete, and the enemy needed minutes or tens of minutes to process a fire mission. Soviet-era doctrine assumed a response time measured in tens of minutes, which gave gun crews enough time to fire multiple salvos and displace before anything arrived. Ukraine, with Western-supplied counter-battery radars and a refined kill chain, compressed that response time by a factor of 5 to 10. The doctrine didn't update. The crews were still operating on assumptions that were no longer true. Intercepted Russian communications from this period show a striking pattern. Crew commanders repeatedly ask for permission to displace before completing their fire mission. They are repeatedly denied. Pressure from higher command to deliver fire support to infantry overrides the survival instinct of the gun crews. This is a systemic failure, not individual cowardice or incompetence, but an organizational culture that prioritized mission completion over crew survival in an environment where that trade-off had become lethal. What's most surprising about this case isn't that crews were caught in firing positions. It's that they kept returning to the same positions. This is where displacement discipline failures became catastrophic. Establishing a firing position takes time. Vehicles need to be positioned, guns laid on azimuth, ammunition pre-staged. Once a crew invests that time in a position, there is institutional pressure to reuse it. The alternative is driving to a new location and spending 20 to 30 minutes re-establishing before firing again. In an environment with heavy fire support demands, reusing positions is operationally tempting. It is also operationally fatal. Ukrainian drone operators in this sector reported something that sounds almost mundane until you consider its consequences. They began recognizing firing positions by the ruts left in the ground. A 27-ton vehicle, driven to the same spot multiple times, leaves distinctive track marks visible from drone altitude. Vegetation gets compressed. Concealment attempts, cut branches, netting, leave a characteristic pattern of disturbance. Experienced operators could identify a reused firing position in seconds. This is the detail that stuck with me. Not the sophisticated radar, not the rocket systems, the ruts, the simple, unavoidable physical evidence of a crew returning to a familiar spot because it was convenient, because it was known, because the alternative seemed harder than the risk. And those ruts became targeting references. The first cluster of confirmed losses in this sector spans approximately a 3-week period. Open-source documentation, geolocated strike footage cross-referenced with unit reporting, satellite imagery from commercial providers, and Oryx standard visual confirmation methodology accounts for at least 7 self-propelled guns in the initial period. The breakdown is instructive. 3 2S-19 Msta-S howitzers, 2 2S-3 Akatsiya systems, and 2 2S-1 Gvozdika 120 self-propelled guns. The Gvozdika is an older Soviet-era system, considerably lighter than the Msta-S, used here for direct fire support to infantry at closer ranges. Each loss follows a recognizable pattern in the footage. The gun is stationary or just beginning to move. The drone footage shows the round arriving, sometimes from artillery, sometimes from an FPV drone delivering final targeting confirmation, sometimes from a direct drone munition strike. The vehicle burns. Secondary explosions indicate ammunition cooking off. The crew is gone, either casualties or abandoning the vehicle on foot. The footage is methodical. There is nothing dramatic about it. That, in a sense, is the point. This wasn't a bold raid or a single spectacular strike. It was a process. Now here's where it gets more complex, and I want you to keep a question in mind. What does a unit do when it realizes it's losing guns faster than it can explain to higher command? The answer, documented through intercepted communications and behavioral changes visible in the open-source record, is that Russian artillery units in this sector went through several phases. First, denial. The losses were attributed to pre-existing surveillance and bad luck, not to a systematic counter-battery network. Second, adaptation attempts. Crews tried shorter firing windows, more frequent displacement, firing from different positions within a known area. Third, and most consequentially, a reduction in firing tempo. That reduction in firing tempo is the strategic effect counter-battery dominance actually produces. It's not just about destroying guns. Every gun destroyed reduces the number of fire missions the enemy can execute. But equally important, every crew that knows their comrades were hit while firing becomes more cautious. They fire fewer rounds. They hold position less long. They displace more often. All of that means less fire support reaching Russian infantry units pressing forward. Consider the arithmetic. A Russian motor rifle battalion attacking a Ukrainian defensive position typically requires sustained artillery support. Preparation fires before the assault, suppression during, and counterfire if the attack bogs down. If the artillery supporting that battalion is firing at 60% of its normal tempo because crews are prioritizing survival over mission, the infantry goes forward with less preparation, less suppression, less protection. Attack success rates fall. Casualties rise. Eventually, the assault doesn't go forward at all. This is how counter-battery dominance in a sector reshapes the entire ground battle. The second cluster of losses, roughly 2 weeks after the first, shows the adaptation attempts in action and their failure. Ukrainian drone teams and radar operators noticed behavioral changes. Russian gun crews were spending less time in any single position. Some were firing on the move, a technique that significantly degrades accuracy but was apparently preferable to being stationary. Some crews were using tree lines and buildings as concealment, positioning guns in or near structures that limited the radar aperture's ability to track outgoing rounds cleanly. These adaptations were partially effective. The kill chain became slightly longer. Some fire missions missed their window, but the fundamental problem remained. The radar was tracking rounds. The drones were covering the area. And the network had enough redundancy that degrading one component didn't collapse the whole system. The detail that illustrates this most clearly is what Ukrainian operators described as pre-plotted coordinates. The counter-battery network wasn't just reacting to individual fire missions. It was building a database. Every confirmed firing position, every reused location, every observed piece of behavior fed into a targeting picture that accumulated over time. Even if a gun crew displaced perfectly after firing, if it had used that position before, the coordinates were already in the system. And if the crew returned, drawn back by familiarity, by established range cards, by pre-staged ammunition, the response was waiting. Think about that from the perspective of a gun crew commander. You are expected to provide fire support. Your infantry is calling for it. Your battalion commander is demanding it. But every time you fire from a known position, you risk a counter-battery strike. Every position you establish is potentially one that's already been targeted. You don't know what the enemy has on you. You don't know if the ground you're parking on has already been plotted in a fire mission that was just waiting for you to return. That is psychological attrition as much as physical destruction. Here's the take that will probably draw some disagreement. The Russian army, in this sector and in this period, was not primarily losing guns because of Ukrainian tactical brilliance. It was losing guns because of organizational failures that Russian command had the information to identify and correct and chose not to. The counter-battery threat was not new. The AN/TPQ-36 and Arthur radars had been operating in Ukrainian hands since 2022. Ukrainian counter-battery tactics had been documented extensively in open sources. Russian forces had 2 years to develop countermeasures, more aggressive displacement schedules, investment in decoy systems, counter-radar jamming, restructuring of artillery command authority to allow crew-level displacement decisions. Instead, intercepted communications suggest a command culture that continued to prioritize fire mission completion over crew survival, one that punished unauthorized displacement even when that displacement was tactically correct, and that treated equipment losses as an acceptable cost of maintaining fire support tempo. The equipment losses were not acceptable. 21 self-propelled guns represents significant combat power. More importantly, it represents the institutional knowledge carried by those crews, the experienced operators, the trained technicians, the commanders who understood their systems. Equipment can eventually be replaced. Experienced crews cannot be replaced quickly. What would you do if you were a gun crew commander in that sector? Every time you fire, you're potentially signing your own death warrant. Your doctrine says fire and displace in 3 minutes. Your physical reality says your gun weighs 27 tons, and the road you're supposed to displace on is a mud track. Your higher command says the infantry needs fire support now. What would you do? Drop an answer in the comments. Seriously, this isn't rhetorical. The decisions made by individual crew commanders in this environment matter, and I think people underestimate how much of this war is being decided at that level. Now, the third phase of losses is where the picture becomes most analytically interesting. By the time the tally reaches the mid-teens, around 14 to 16 confirmed losses, something changes in the open source record. The firing tempo from Russian artillery in this sector drops sharply, not gradually, sharply. Satellite imagery shows gun positions being established further from the front line, outside the optimal range for some targets. This means less accurate fire and longer time of flight for the shells, which gives Ukrainian troops more warning and more time to take cover. It also means the Russian guns are now at the edge of, or slightly outside, the effective range of certain Ukrainian counter-battery systems. This is adaptation. Deliberate, documented, and partly effective. The kill rate slows, the losses continue, but at a lower tempo. But there's a problem with this adaptation that becomes visible in the next layer of data. At the same time, Russian guns were pulling back to safer ranges. Ukrainian forces in this sector were maintaining their defensive positions and, in some areas, conducting local counterattacks. Those counterattacks required fire support. With Russian artillery degraded and displaced to greater distances, that support was weaker and less accurate. Russian infantry units attempting to maintain pressure on the Ukrainian line were doing so with degraded fire support. And degraded fire support against prepared defensive positions is close to no fire support at all. Intercepted communications from the period when the tally was moving toward 20 guns show exactly this dynamic. Russian infantry unit commanders asking, sometimes demanding, more fire support. Artillery commanders explaining they cannot fire from certain positions without risk to the guns. Higher command ordering continued fire support. Artillery commanders complying and losing more guns. Here's what this tells us about artillery doctrine in this kind of war. The tension between fire mission requirements and self-preservation creates a command system that's fundamentally unstable. If you protect your guns, you fail your infantry. If you support your infantry, you lose your guns. There is no stable solution to that problem without one of two things. Either dramatically faster displacement that outpaces the counter-battery cycle, or suppression of the enemy's counter-battery radar and drone network. Russia attempted neither effectively in this sector. If you've been following this conflict closely, you know that Russian forces have invested in counter-drone capabilities, electronic warfare systems, RF jammers, the Krasuka-4, and Borisogledsk-2 platforms. These systems can disrupt commercial drone communications. But the counter-battery network Ukraine was running in this sector didn't depend entirely on commercial drone communications. Fiber optic guided drones, offline navigation systems, and diversified communications protocols meant that partial electronic warfare jamming degraded but didn't eliminate Ukrainian reconnaissance capability. Here's something that wasn't widely anticipated going into 2024. The civilian drone ecosystem proved more resilient to military-grade electronic warfare than the military communications systems it was supplementing. The Mavic 3 and similar commercial platforms, modified with signal-resistant firmware and operated with improvised counter-jamming measures developed by Ukrainian volunteer engineers, continued to function in contested electromagnetic environments where more expensive military systems sometimes struggled. The 21st confirmed loss in this sector, the one that completes the tally, is documented through a combination of drone footage and satellite imagery. The satellite image, from a commercial provider, shows a vehicle-sized burned patch at a location that had appeared in Ukrainian targeting databases as a recurring firing position. The drone footage, geolocated to the same site, shows the aftermath of a strike that caught the gun either just before or during displacement. The vehicle is destroyed. There is no secondary explosion large enough to indicate a full ammunition load, suggesting the crew had either expended most of their rounds or moved ammunition separately, a sign that some adaptation had occurred. The gun was nonetheless destroyed. The strategic accounting for 21 self-propelled guns in a single sector runs into the tens of millions of dollars in direct equipment value. A 2S-19 Msta-S costs approximately $3 to $4 million. The older 2S-3 Akatsiya, perhaps $2 to $3 million. At conservative estimates, the equipment losses represent $60 to $70 million in destroyed Russian military hardware. Add the ammunition expended by Ukrainian forces in counter-battery missions, and the cost-exchange ratio still favors Ukraine significantly. Counter-battery fires with artillery and rocket systems are expensive, but cheaper than the systems they are destroying. The dollar figure, though, is less important than the operational accounting. 21 self-propelled guns removed from a single sector represents a significant reduction in Russian fire support capacity. Russian motor rifle units in that sector, relying on artillery support for their attacks, found themselves conducting operations with substantially degraded preparation fires. According to Ukrainian General Staff reporting, which must be treated as partial and potentially optimistic, at least 3 planned Russian assault attempts in this sector were delayed or abandoned during the period of maximum artillery attrition because the fire support required to enable them was not available. 3 delayed or abandoned assaults. In a war where Russian strategy has repeatedly relied on grinding attrition through mass assault, the ability to interrupt that rhythm even temporarily carries real strategic weight. Here's where the lessons sit at a level above this specific sector. Counter-battery dominance is not permanent. It is earned and maintained. The moment counter-battery systems are disrupted by electronic warfare, by enemy counter-battery fire, by attrition of the radars and drones themselves, the situation reverses. Russian forces know this. They have been attempting, with varying degrees of success, to target Ukrainian counter-battery radar positions since 2022. The Arthur radar systems have been targets of Russian missile strikes on multiple occasions. This is the ongoing duel within the duel. Counter-battery warfare is not just about destroying guns. It's about destroying the networks that enable counter-battery fire. Ukraine disrupted Russia's artillery. Russia attempts to disrupt Ukraine's sensors. The side that maintains network integrity longer wins the sub-battle. In this sector, during this period, Ukraine maintained network integrity long enough to account for 21 guns. That is not a final victory. It is a tactical advantage that, compounded across multiple sectors, translates into operational advantage. The ability to hold defensive lines, conduct limited counterattacks, and deny Russia the fire superiority it needs to achieve breakthrough. When you think about what a similar concentration of sensor-to-shooter capability looks like applied at scale, two historical comparisons come to mind. The Gulf War artillery duels of 1991, where coalition counter-battery systems dismantled Iraqi artillery in remarkable time, and the 2006 Lebanon War, where Hezbollah's dispersed firing positions frustrated Israeli counter-battery efforts for weeks. Both cases suggest that counter-battery dominance is achievable, but not permanent. It requires constant maintenance, adaptation, and willingness to keep feeding resources into the network, even when the tactical situation seems stable. The Ukrainian model in this sector, radar, drone confirmation, rapid fires, is not technologically exotic. It is the careful integration of available systems with trained operators and refined procedures. Other nations studying this war are looking closely at exactly this aspect, not the platforms, but the procedures, the kill chain, the time from detection to fires. NATO doctrine has been moving in this direction for years. What Ukraine has demonstrated is that the theory works in practice against a peer or near-peer opponent in contested airspace with degraded communications under active electronic warfare pressure. That empirical validation is worth more than any training exercise. The question is whether Russia can close the gap. Team comment for you. Will Russia successfully adapt its artillery tactics in time to prevent further losses at this scale? Yes or no? The comment section is your answer. We read every one. There are 3 questions worth sitting with as we close. Could Russia have prevented these losses? In principle, yes. More aggressive displacement schedules, decentralized command authority, allowing crew-level decisions, investment in counter-radar jamming, and a culture that genuinely prioritized crew survival over mission completion would have reduced losses significantly. Whether those changes were organizationally possible within the Russian military as constituted, that's a harder question. Institutional culture doesn't change quickly under fire. What does this mean for NATO doctrine? The sensor-to-shooter timeline demonstrated in this sector, detection to fires in under 8 minutes, in contested conditions, should be the baseline expectation for any future near-peer conflict. Artillery units that cannot displace in under 3 minutes, that lack the communications infrastructure for rapid kill chain processing, and that operate on doctrinal assumptions about enemy response times based on Cold War scenarios, are dangerously exposed. Every NATO artillery brigade commander should be studying these numbers. And the final question, what comes next? Russian artillery forces have been adapting throughout this war. They are not static. Expect continued evolution in Russian firing techniques, shorter exposure times, increased use of autonomous firing systems, attempts to degrade Ukrainian counter-battery networks through targeted strikes. The 21 guns in this sector are a data point, not an end point. The historical parallel that lingers. Similar sensor-shooter integration failures defined German artillery losses during Operation Bagration in 1944, when Soviet counter-battery forces achieved rapid kill chains that Soviet doctrine had been developing since Stalingrad. The Red Army had 2 years to refine their counter-battery process. Ukraine has had 3. History suggests that once these advantages are established, they are hard to dislodge quickly, but that the losing side will eventually adapt if it survives long enough to do so. What this sector tells us in the end is straightforward enough. Artillery is not a blunt instrument. It never was. But for decades, the friction of war, slow communications, incomplete radar coverage, limited drone availability, meant that the gap between firing and dying was wide enough for crews to survive their own exposure. Technology has closed that gap. In this sector, for these 21 crews and their guns, it closed completely. The next sector will look different. Russian forces will adjust. Ukrainian forces will adjust to the adjustment. That is the nature of this war, not a single decisive moment, but an ongoing technical and tactical competition, sector by sector, gun by gun, radar track by radar track. We cover that competition every week. The investigations are ongoing. The data is being collected, confirmed, and analyzed. If that kind of rigorous OSINT breakdown is what you come here for, subscribe. Hit the notification bell. The next analysis is already in development, and the story it tells is at least as consequential as this one. 21 guns, one sector, a network that hunted them systematically, patiently, and without pause. That is what counter-battery dominance looks like from the inside.